Hi, fifth grade. Here we are on page 31 of our SAB, and we're going to do the first of two reviews for the Unit 1 test. So this review will cover pages 31, 32, and 33. You will need to have scrap paper available, or your whiteboard, that's fine too. It says, choose the symbol from the box to compare the fractions. Looking at these, a couple of them have some things that make them a little bit more easy to compare, and some of them we're going to need to actually set up a common denominator showing of our work in order to compare them correctly. Thinking through these very carefully, you can always set up what I'm about to show you, what I'm about to review with you if you need to. So never feel like you have to solve these mentally. I'd much rather you show your work. Okay, but let's first look at number 1. We did learn something about fractions that have the same number in their top, in the numerators, and this is back from 4th grade. If you remember correctly, if the number is the same in the top, then looking at the bottom, the number that has the smallest number is going to be the largest. And that makes sense in practical ways. You could, if you think about it, if you think about, oh, I have a pizza and it's divided into 6 slices. I get to eat 4 of them. Same size pizza is divided into 5 slices. I get to eat 4 of them. Those are going to be slightly bigger slices. So 4/5 will be larger than 4/6. Okay. 7/12 and 3/7. Another strategy to use that we've talked about when we're comparing fractions is to think about, are they close to 0, are they close to 1/2, or are they close to 1 whole? Both of these seem very close to 1/2 to me. 7/12 is slightly larger than 1/2 because I know that 6/12 would be 1/2. Now 3/7 is slightly smaller than 1/2 because if I think about the number 7, half of number 7 is in between 3 and 4. It's 3.5, right? So this is actually less than 1/2. This is more than 1/2. So which would be greater? 7/12. So you can see how you can definitely use some mental math strategies, and that's what they're trying to show us here on these first few. So looking here, we have 3/10 and then we have 4/11. Now this one's tricky because these 3 and 4 are close together, 10 and 11 are close together. They're just one off. So we're going to prove this one with our scrap paper. So go ahead and make sure you have it ready to go. Yes, you are required to set this up right now with me. I don't want you to just watch it. Oops. I was getting ready to set up for addition, but we want to set up for comparing. So with comparing, we're going to set up each fraction on a side of our comparison circle. And then we can still, this part's going to look very familiar to what we do, obviously, when we add and subtract fractions with different denominators, except it's branching off from both sides. So looking to find our new common denominator there, and there are circles to represent that. We're trying to figure out a number that both 10 and 11 go into. We might as well just go ahead and go 10 times 11 on this one. So 110, I think that's actually the only one that will work. Okay, 10 times.
All right, one more message to everybody.
Mr. Anderson.
Confirm that there is a pretty significant leak, so the water is going to be out for the entire day and evening, and we'll return in the morning. But it's a pretty big leak.
Sorry, guys. I don't want to start this video over because I already went through that part. So you got to hear Mr. Anderson's message. 10 times 11 equals 110, and then the 11 has to be up there as well because it has to be the magic one. 3 times 11 equals 33. Okay, now 11 times 10 is 110, 4 times 10 is 40. Okay, so now I can confidently see which fraction is greater, and it is 4/11. So I just wanted to show you also that you can always set it up like this. In fact, often you should be setting it up like that. Okay, number 4. Gershon lives 3/10 of a mile from the soccer field. How far does Gershon walk if he walks from home to the soccer field and back home? So 3/10 of a mile, he walks home, he walks to the soccer home and then so back and forth, in other words. So looking at 3/10, what would we have to do? We would have to double it, right? So if it's 3/10 one way, and then it's another 3/10 the other way, then we are thinking about adding two fractions that have the same denominator. When two fractions have the same denominator and we're adding them, the denominator stays the same and we're only adding the numerator. I think probably most of you remember that. And then because we are in 5th grade, we have to simplify now. So 6/10 gets simplified or reduced to 3/5. And that is because both 6 and 10 can be divided by 2. 6 divided by 2 equals 3. 10 divided by 2 equals 5. Number 5. Anton shoveled snow on 4/6 of his driveway before lunch. You can see that represented in yellow. Then he shoveled 2/6 of it after lunch. There it is in white. How much more of his driveway did Anton shovel before lunch than after lunch? So we've got our how much more. There's a clue word that we recognize, so we know we're going to be doing a subtraction problem. Again, the fractions have the same denominator. So this makes it really easy. If they have the same denominator, you're just really working with the problem that's on the top, and that's just 4 minus 2, because your bottom number, your denominator, will stay the same. 4 minus 2 equals 2/6. We do have to reduce or simplify, so 2/6 would go down to what? Well, 2 can be divided by 2, and 6 can be divided by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So our answer is 1/3. Moving right along to page 32. Here we have a word problem about Marcus. Marcus and his family spent 1/2 of their vacation visiting relatives and another 4/12 of it at the beach. What fraction of their vacation did Marcus and his family spend either with the relatives or at the beach? I really like this model, although they could have done a better job with the coloring of these. You can see that the dark yellow is showing 1/2, so we could even draw a line there. So all of this side is 1/2, so that is the visiting of relatives, and then 4/12 is shown here. So you can see that all together this is divided into 12 sections. 1, 2, 3, 4 of them are showing this 4/12. What fraction did they spend in yellow either way? So dark yellow or light yellow. So of course we're looking at 1/2 plus 4/12. Now we could find a common denominator. We could change the 1/2 to a fraction that has a denominator of 12. But this model is showing us that we can also just use the model to help us. So we know there's 12 altogether. How many are shaded either color of yellow? 10, right? So 10/12 is going to be the full amount. Do we need to simplify that? Yes, we need to reduce that. Both 10 and 12 can be divided by 2. So we divide it by our magic 1 of 2, and that brings us to 5/6. 5/6. 10 divided by 2 is 5. 12 divided by 2 is 6. Camille uses 4 2/3 yards of white lace and 3 2/3 yards of ivory lace for a craft project. Write and solve an equation to show how much lace Camille uses. Draw a model to show how you solved the problem. Okay, so we're taking both of these and we are going to be adding them together because we want to see how much she uses all together. It does say to write an equation, so that's what I'm doing first. Make sure you write your equation as well. And it's nice because, again, these denominators are staying the same. So I really don't have to set this up. I can just add my whole numbers. 4 plus 3 equals 7. Denominator stays the same. Numerator, 2 plus 2 equals 4. Here's where it gets a little bit tricky. We have 4/3 there. What's wrong with that? That is an improper fraction. So I have to divide it. I have to take that 4, put it inside my division bracket. 3 is on the outside. 3 goes into 4. one time. Remember, this remainder becomes the numerator and the denominator stays the same. But is that my final answer? Remember, that is only representing the 4/3. So now that I've changed what 4/3 looks like, I'm going to go back to the 7 and add it to the 1/3, 1 and 1/3. 7 plus 1 equals 8. So 8 and 1/3. That's my final answer. Now, they want us to draw a model. So your model, it's really important that you are thinking about what your model would look like. I'm going to do mine on scrap paper because I've run out of space there. 4 and 2/3 plus 3 and 2/3. So here I have 4, and then I'm going to put my extra bar here for the 2/3. So 1, 2, 3, 4 wholes and 2/3. Okay. Now for the other number, 3 and 2/3. Now, here is where you would be doing some circling like we did last year, where you would move part of this down so that we could have a whole. So because we can't really have an answer with two fractions, do you see what I mean? Like there's 2/3 here and there's 2/3 here. That won't work in our answer. When we model it, something we want to show it with the final answer as well. So what you can do is you can just circle, maybe with some nice colors or highlighters if you have them, one of the thirds here, draw an arrow, maybe shade it like a different way, lighter or something, to show that that moves there, and then that one would stay the same. There are several different ways you could set up a model, but this one would do just fine. It really shows that you're putting the two together, that you're regrouping this 1/3 to go into there. That way you can easily see that the answer is 8 wholes and 1/3. Let's see if that's what we put. Yay, 8 and 1/3, good. Okay, the project requires a total of 10 and 2/3 yards of lace. How much more lace does Camille need to finish the project? So this is how much she has now. No, this is how much she has used. It requires this much. So how much more does she need? I think we can take these two and use them as our comparison numbers. 10 and 2/3 is how much altogether, and then minus the 8 and 1/3. That's going to give us an answer of how much more she needs to finish this project. So again, the denominators are the same, so it's making our lives pretty simple right now. Whole numbers, 10 minus 8 equals 2. Numerators, 2 minus 1 equals 1. Yay, I don't have to regroup or anything. This looks like a fraction that is good to go. I don't even have to simplify it. 2 and 1/3 more yards. I forgot to label up here, and I should not forget to label. That is really important. So again, we are looking at yards up there. All right, here's our last page for this section, and then we'll do the other half another time. Select the fractions that are equivalent to 3/4. Mark all that apply. So when you're looking at this, you're trying to see, can a fraction be multiplied by a magic 1 to get to 3/4? Or can it be divided by a magic 1 to get to 3/4? It could be multiplied or divided. In fact, these are all going to be divided mostly because 3/4 is so small. But I can't think of a way that 4 could be divided to get to 3. Can you? No. 12 could be divided by something to get to 4, but 4 could not be divided to get to 3. So there's no magic 1 that will take us to 3/4. This doesn't exist. There's nothing that says 4 divided by 3 by something equals 3, and then that same number, 12 divided by that number equals 4. So it doesn't work. That one's not going to work. What about 15/20? So 15/20, is there something that I can divide? I'm going to have to go down here a little bit, aren't I? Can I divide 15 and 20 by something to get to 3/4? Well, 15 divided by what equals 3? 5. And then I have to keep the 5 there so that I have my magic 1. And so I've got 5 over 5 equals 3/4. So 20 divided by 5 equals 4. So you can see that I've got the magic one there, and I've got the 3/4 there. So that will work. I can go ahead and shade that one in. So on the rest of this, I'd like you guys to go ahead and solve the rest of them on your own as much as possible. Just do your best, and if you have any questions, you can let me know. Number 9, write two fractions that are equivalent to 8/12. Draw a model that will split fraction bars to justify your answer. So we're going to draw a model first, and we're going to make it 8/12. One, two, three, 4, 5, 6, 7, 8. Okay, so this here is 8/12. Now we need to come up with two fractions that are equivalent to 8/12. I'd like to go down because I think it'll be easier to draw the model. So if this is 8/12, can we think of anything we can divide both 8 and 12 by? What if we divided them both by 2? 8 divided by 2 equals 4. 12 divided by 2 equals 6. Aha! So 4, 6. And again, with the requirement of the model here, we're going to shade in 1, 2, 3, 4. And your model, you can even kind of sketch a line there to prove that that is equal to each other. So there's 4/6. Now, is there another fraction? Can 4/6 be simplified even further? Yes. 4 and 6 can both be divided by 2 again. If I divide 4 by 2, I will get 2. If I divide 6 by 2, I will get 3. So my new fraction would be 2/3. So again, I'm going to set up my bar. One, 2. So something like that. So you can show the model and you can show the equivalent fractions.